Hello everyone, welcome to Cyberducky. Today our 8th day, and before we start the day I want to thank everyone who have subscribed my channel, and thank you very much for your time and subscription. And if you are not subscribed, please subscribe to the channel to help me to grow the channel. Today we're gonna look at our 8th day at ducky.com, and we are an IT guy who learning basic network skills to build our network career. So if you see in my previous video, I have shown how much an annual salary approximately a network engineer makes. Based on your experience, it can go up to 150, 100k Sing dollar or even USD as well, but depend on country to country, your pay scale may different, but it's very highly paid career. So I just want to highlight that, and thank you for your time again. Let's start today. So yeah, we had 8 day, and what we're going to look in today is that we're going to discuss today about something called Router Redundancy Protocol. So we're going to learn a new skill, how to create routing redundancy. So let me explain what we're gonna do. Okay, let me bring up, this is our packet tracer diagram what we working. So the gateway for this network is over here. So this is where our gateway for all these VLANs, right, all these sales, marketing, IT, and meeting room, HR. So this all will be in this here as a gateway. Okay, so what is route redundancy protocol? So we know in route redundancy means we have two gateway. Okay, let me explain the problem first here. So if you see here, we have two sales PCs, right, which is under let me clear it, this one. So we have two sales PC, two marketing, but it's two are different VLAN. So I think the sales is 10, marketing is 11. So they need a gateway to communicate, and the IP range also. So the sales is 192.168.0, and the marketing is 192.168.10/24/24. So 1 and 2 are 1 2 IP address. This one's a 1 and 2. Same way we have IT also. IT, I think 192.168.2.series/24. Let me double check quickly. Yeah, so these are the VLAN information and ID. So 92, right? Correct. So these are the IP range and IP information. So the problem here is we need to have only one gateway for all these VLANs. So again, VLAN 10, we have used 1 and 2 IP address for these two systems. So we can use the last IP address, which is 192.192.168.0.254 is a gateway, right? So if you use this gateway on these switches, if you see here, we have two switch. So if we configure this one over here, and if this one goes down, then this system cannot communicate to this one, right? So we need to make sure that this IP, the 254 IP, which is 254 IP for the VLAN sales, should be able to reach by these two systems even this one is down. So meaning, in other words, this one, so sorry about that, so even this switch is down, you should be able to go to this one, right? So that's what we want to do. For that, there are a few protocols in routing, what you call virtual routing or router redundancy protocols. Not yeah. So we have two kind of a protocol. Let me. So one is VRRP, one is HSRP, one is GLBP. So difference is these two belongs to Cisco, meaning they are the one who created these two protocols. So it's a Cisco proprietary. Maybe I'll spell it wrong, but today we're going to focus on the VRRP. So this one is virtual route redundancy protocol. This is a common one used. I mean, when I say common, it's used by other vendors, not only Cisco, because it's a industry standard one. So it's used by Juniper. It has been used by Cisco, other vendors. Meaning to say, let's say we have let's say we have a similar scenario. This one is, let's say, R1, this one R2, this one is Cisco, this one is Juniper. So they all connected to these switches here. This is the switch, and let's say this one is the PC. So if you see, even though these are two are different brands, they can work with VRRP to give this PC one gateway, so that it can go with one way. Even if Cisco is down, the traffic can go through the Juniper. So that's what we want to achieve in this video. Okay, so I'll show you the configuration and all. Before that, let me give you how it works. So it's a per VLAN base, right? So we need to have a VLAN interface created. So we need to create a VLAN interface for this sales and marketing, and we are doing IT as well in this video, not IT. So these VLANs, we will create a VLAN interfaces in these two switches. Then we'll create a virtual router with a VRRP, not virtual route, actually it's called Virtual Redundancy Protocol, router protocol, because virtual router is a different concept. So this common interface will be used as a 254 from all the network to go as a gateway. Okay, so for that we need to create a VLAN interface here with one IP, same in this particular each subnet of this. Again, we need to create one VLAN interface here with same concept with all individual VLAN. Then we need to create one VIP, virtual IP, so so that these systems from here, they can communicate to this particular VIP, and then they can go out. Okay, let's go to the configuration and let's start with our packet tracer. And so what I have done is that I have created all the VLANs, necessary VLANs, all the way from here and here. So we're going to work only on these two systems, so that we don't need to jump here and there. Before that, let me see the IP configuration here. If you see here, sales PC1 is gateway is 254, and marketing also, this one is 11 is 1254. IT, we have two system. Let me check here, IT 2.2 and the gateway. So for example, if you want to test, let's see the connectivity, which other things working. I already tested. Let me show you guys. The ping tool, and 192.168.2.1 is the laptop replying. If I try to ping 2.254, it won't reply because I never configured. Same way, 0.254 is not working because I never created. Then 0.1, which is sales PC1, also not working. So this is the evidence that we tried is not working. Okay, I close this. Let me open this, make it a little bit bigger. VLAN switch 1, show VLAN. Right, so show VLAN is showing us the sales, marketing, IT, and prod. So we have all the VLAN we need. So we're going to work only these three VLANs today. So I need to create interface. So let me take so what I'm going to do is, we know we're going to use the IP address 254 as a virtual IP. So I'm going to use 252 for this interface here. Meaning, say, okay, let's create a VLAN interface for sales. To create a VLAN interface, what you need to do is conf t interface VLAN 10. So the VLAN 10 is the sales, right? So I need to create a VLAN interface on 10. So you can see VLAN interface is up. So I need to give an IP address. I give IP address is IP address 0.252, which is we're going to use here 0, no shutdown, even though it's up. So we can see show IP interface brief. We have this one configured already. We can test this 192.168. 0.1 should reply. Yeah, see, it's replying. 2 also should reply because the 2 exists. Okay, so same way we go to switch 2 and do the same thing. We create okay, let me, where's that? Sorry for the slow. Okay, let me put it to behind next to each other and show VLAN again. So it's good because we have VLANs are correct. So we're going to work with first VLAN 10, which is sales. Interface VLAN 10, IP address 192.168.0.253. So you're going to use 253 and subnet is 255.255.255.0. No shard, no need, but I put again, we can see ping 192.168.0.252. So if we can ping means, yeah, so we have the communication between two, and we can test that one also, communication for PC 1, 2 and 1 also. So my point is, we have the communication from these two systems all the way here, then it's all the way here, so they are able to communicate with all of this. The end-to-end connectivity is very good. All right, so we are in here. I'm sorry, I had to pause and check something. So unfortunately, in switch of this packet tracer, there is some limitation. We cannot create VRRP, so I'll be working on HSRP. So it's both same concept, is the same thing it'll be doing, only the name different. So we will configure that one in this scenario, but in future, if I can, I'll try to do different lab with where I can show you how to configure the VRRP. So to configure the VRRP, let me exit here, let me show you what we need to do. So first we need to go to config mode, interface. So we created already VLAN interface 10. So inside there, we need to go to standby. So in standby, we need to create a group ID. So in this case, I create 10 because since the VLAN is 10. Then I need to give a, what do you call it, enable HSRP, set in a virtual IP. So I need to give it a VIP or virtual IP. So for that, I need to give IP. Then I need to give the IP address is 192.168.0.254. So this is our VIP. Enter. And the priority level, so the priority level is, I think, the lower the priority it takes, meaning if you have 1 to 100, let me if you go 10, then see, we are getting the HSRP update. It's become a standby to active, so we can see priority, we can use up to 254 priority the value. So if I didn't give anything, I just leave it to the auto. So show stand IP stand, is it? No. Standby brief. So what's happening here? So it's using VLAN 10, correct, and the group is 10, priority is 100, and this one is active. So standby is unknown, so it doesn't know which one is a standby. So that's why we need to go inside here. Again, same config T interface, VLAN 10, standby, group is 10, and IP 192.168.168.0.254. Show standby brief, still unknown because it's using also. Okay, so we see here speak to stand, it becomes standby, I think, local standby. Yeah, so let's see brief, both of them. Let's see what is the priority for other one, maybe I think. Yeah, so this one is active, this one is I remember, if I'm not wrong, it should be lower priority. Let's change. So since this is a standby, let's see if we change the priority to lower than 100. If standby priority to 90, see what happens. Is it change, or is it stay as it is? Looks like it doesn't change. Oh, it doesn't change yet, priority. It's taking time. Let me interface VLAN, then shutdown, no shutdown, show standby brief, show standby. Show running config. Let's see what it's saying here. Oh, my mistake. I never put the group 10. Interface VLAN 10 standby 0. Standby 10 priority 90. Show standby priority. Okay, still it stays. So I mean the lower is not, the higher is the, I think it needs to be higher. Interface VLAN 10, standby 10, priority 110, show standby brief. listening, speaking. Yeah, I think I made a mistake again, because it's become higher than become, let's maintain back to 90. Shut down and not shut down. Listening, 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 listening. Speaking, speaking. It's become standby. What it says? Okay, because of, I think preempt is not enabled, so that means, okay, let's enable the preempt. Config interface, VLAN 10, standby 10, preempt. VLAN 10, standby. Okay, anyway, I don't want to waste much time here. Standby, brief, speaking. But preempt is basically means, like, you know, if let's say this one is in this case active here, right? So if it goes down this system, then it will come up. But if preempt is not enabled, then it will stay as it is. Then if you want to course which want to become again primary, then you need to enable the preempt. That's what it means, but I don't know. Okay, standby for some reason. Okay, never mind, we'll try on the other one. Okay, so let's try the connectivity from below. So I go to terminal here, ping 2168.254. Yeah, so I can reach gateway, but the question is, can I reach to IT1? No. The problem here is a routing issue. So what's happening is, these two systems, I don't know whether it's clear or not, these two systems already know it's gateway. Even if this one doesn't work, it should work. How we can test that? So what I'm gonna do is, I'm gonna shut down this. Okay, let me save the configuration. I don't want to. So we know this one is standby, active is this one, right? So let me do one thing. I'm gonna physically shut down this. Oh, I think I should have done something. N. So as you see, it's still pinging, so that means it should have kept that. Yeah, so you see here is active. So what we'll do is, I will power up this and see what happens, whether any ping drop here once it comes here. So it's loading. I know it will take some time. I pause for a while until it boots. I don't think so I can. Okay, it's boot. So it is boot. So based on preemptive, once it's ready, it should be. So standby is unknown yet. Okay, we have the message here saying group 10 standby become active. So this one should be standby now. Not yet. Yeah, so this one's standby here. So we see some ping drop. Okay. It shouldn't be this much of ping drop. I think in real life it will be less than this. Yeah, so we didn't do anything. We saw it comes down active. Show standby brief. So this is active, this is standby, right? This one is standby. So let's try again, shut down, and see if we need to switch to the secondary, it takes the same time or not, because this experiment we didn't do. Okay, shut down, done. So this one dropped 3-4 ping. Let's see. Yeah, it's also dropped, become active here already. How long it takes? 2 ping. So when it's active to fail to when it's active, fail to secondary or the standby, it failed 2 ping, 2 drop of connectivity. But when the preempt enable, then this is become a problem. Okay, So this is done for today. I don't want to take more longer. So next call or next video, I will create another VLAN or another interface. We do the same exercise, and for the different VLAN, which is maybe IT, then we try to communicate between these two. It's already coming to more than 20 minutes, so I don't want to take too long. So we'll do it again next call or next video, follow up of this with the two different VLAN and how it's behave. Or maybe we can try GLBP with the other one. So one is HSRP and one is GLBP. So we do that in the next call. Okay, thank you for your time. If you're not subscribed, please subscribe, and please feel free to comment whatever questions you have. If you have any question about network engineering or cybersecurity, feel free to message me in the comment. I'm happy to answer any of those questions. Thank you for your time today.